MHF4U Grade 12 Functions, Section 2.3. Today we'll be discussing how we can explore instantaneous rate of change in greater depth using graphs. So the first thing we talk about then is the tangent line. Now I've introduced this previously in other videos, but the tangent line is a line that touches the graph at only one point, P, at a small interval within a relation. So it could be that it does not have to cross the graph at other points outside the interval. So the tangent line goes in the same direction as the relation at that point P, called the point of tangency. So this is the point of tangency. And what they're saying is that this is where the line touches the graph, and it just could happen that it also crosses through other points of the graph. But all we care about right now is just the tangent line right there. So when it touches that point at the point of tangency. Okay, so key summary then about the tangent line. So the slope of the secant line is equivalent to the average rate of change over the interval divided by the x-coordinates of the 2 points that are used to define the secant line. But the slope of the tangent line is a point on the graph that is equivalent to the instantaneous rate of change of a function at that point. So we talked about this previously as well, but when we look at the secant, it's always over 2 points, right? But the tangent would only be over 1 point. So that's all they mean right there between the difference between the secant and the tangent. We need to know then that the slope of a tangent cannot be calculated directly using the slope formula. In fact, you'd actually need to use something called derivatives, which you'll learn in the future in your calculus class, I believe. But for now, we can only really estimate the slope of the tangent line. So it can be calculated by using the slope of a series of secant lines that go through this fixed point of tangency P and gets closer and closer and closer to this fixed point. So this might look complicated, but all they're doing, using Q1, Q2, and Q3, is they're going to find the slopes of these tangent lines that are really, really close to our desired tangent line, and then we can average them out because we're using points that are both a little bit bigger and a little bit smaller than our desired tangent line. So that's it for this video. It's a really short one, but we just wanted to introduce the tangent line, explain how it applies to the instantaneous rate of change. And again, so just to clarify, the tangent line is at a specific point, and that's how it differs from the secant. And if you want to connect the algebraic and graphical meanings of this, you can see that the instantaneous rate of change will always be at only 1 point, and that's why we would use a tangent line in this case. So with that, I hope you enjoyed this video. As always, if you have any questions, feel free to contact us on our website, passionatemind.com, and thanks for watching.